Climate change is an ever-growing catastrophe, threatening to destroy humanity. So far, efforts to curtail its devastating effects have been marginal. With rising sea levels, warming temperatures, and more natural disasters, we must ask ourselves, how can we hasten the impact of the detrimental effects of climate change? Here are 6 options for removing carbon from the atmosphere. Number 1. Increase the number of forests. Carbon dioxide can be slowly eliminated from the Earth's atmosphere through photosynthesis. Trees store carbon removed from the atmosphere by photosynthesis. Growing, preserving, and managing forests to encourage greater carbon uptake could raise the potency of photosynthesis globally, converting carbon dioxide in the air into carbon stored in wood and soil. Forests are a sustainable force for the climate. They regulate environmental conditions. Around 2.6 billion tons of carbon dioxide, a third of the CO2 released from fossil fuels, is absorbed by forests annually. Predictions suggest that close to 2 billion hectares of degraded land worldwide, an area the size of South America, offers a chance for reforestation. Increasing and managing forests is therefore a critical solution to climate change. Then there's the Bond Challenge, a global operation to bring 350 million hectares of deforested and degraded land under preservation by 2030. Reaching the 350 million hectare target could separate nearly 1.7 gigatons of CO2 yearly. Number 2. Farms. Soils store carbon, but agricultural soils are being overused at the moment because agricultural land is so expansive. Even tiny increases in soil carbon per acre could be impactful. Building soil carbon is good for farmers and ranchers too, as it can increase soil health and crop yields. Integrating trees on farms can also remove carbon while providing other benefits, like shade and forage for livestock. Land-based ecosystems have the ability to absorb 22% of global greenhouse gas emissions through natural carbon processes. Forests, seagrass, and wetlands are classified as carbon sinks. In terms of efficient irrigation management, conserving water is vital to any farm, particularly in times of drought. But given that the majority of energy used on farms is from groundwater pumping, irrigation efficiency is also key to reducing fossil fuel consumption and GHG emissions. Water and climate-wise farmers can use an arsenal of methods to save water and reduce energy consumption, such as dripping irrigation, planting cover crops, dry farming, and more. As for renewable energy, maximizing energy efficiency and shifting away from fossil fuels are important steps that farms can take to reduce their climate footprint. This can include on-farm renewable energy production such as solar panels and wind turbines, minimizing use of petroleum-based fertilizers and pesticides, and reducing dependence on fossil fuel inputs for farming, storage, and transportation of crops. In terms of organic practices, the industrialization of agriculture has led to widespread dependence on petroleum-based pesticides, herbicides, and fertilizers in conventional farming. Number 3. Bioenergy with carbon capture and storage, or in other words, BECCS. The process of using biomass for energy in the industrial, power, or transportation sectors, capturing its emission before they are released back to the atmosphere, and then storing that captured carbon either underground or in long-lived products like concrete. If BECCS causes more biomass to glow than would otherwise, or stores more carbon instead of releasing it back into the atmosphere, it can provide net carbon removal. However, care must be taken to ensure that emissions from the growing, harvesting, transporting, and processing of the biomass do not outweigh the captured carbon, and that the storage of captured carbon is reliable over long timescales. Estimates for the potential scale of BECCS vary widely. A recent expert assessment estimates potential sequestration rates of 0.5 to 5 billion metric tons of CO2 per year in 2050, with the possibility of much higher rates by 2100. Scenarios compiled by the Intergovernmental Panel on Climate Change suggest that limiting warming to 1.5 degrees to 2 degrees at the end of the century could involve sequestering roughly 5 to 10 billion metric tons of CO2 per year via BECCS by 2100. Such projections have been met with intense skepticism, partly because of land use requirements. A recent study from the US National Academy of Sciences estimates a global potential to sequester 3.4 to 5.2 gigatons of CO2 per year via BECCS without large adverse impacts. Cost estimates vary widely, with one's recent expert assessment projecting costs of US dollars 100 to 200 per ton of CO2 sequestered, and another projecting costs of between 20 US dollars to $100 per ton. In terms of direct air capture, being number 4, the process of chemically scrubbing carbon dioxide directly from the ambient air and then storing it underground or in long-lived products removes excess carbon directly from the atmosphere instead of capturing it at its source. The air-captured carbon dioxide can either be recycled and used as a raw material or completely removed from the air by safely storing it. Lastly, at number 5, we have carbon mineralization. Some minerals naturally react with CO2, turning carbon from a gas into a solid. Carbon mineralization can also be used as a way to store CO2 by injecting into suitable rock types where it reacts to form a solid carbonate.